In this problem, we have joint density function of x and y. So it is kx when y is in this region and x is in between 0 and 1. So first part is asking find the value of k that makes this function a probability density function. Before I start this, I need to understand the region and how many inequality we have. First one, x minus 1 less than y. So I will write down this as an equation, y equal x minus 1. So we can draw this equation in this coordinate system, y equal x minus 1. So this should be negative 1 and this should be 1. So this is the equation y equal x minus 1. Now go back to the inequality. So we have two regions, the region above this line and below this line. So which one does satisfy this inequality? Yeah, it satisfies the region above the green line. Okay, we have another inequality, y less than 1 minus x. So y less than 1 minus x. I can write down this as an equation like x minus x plus 1. So if I draw this line here, the same coordinate system, so we will get this y equal negative x plus 1. Now understand the region y less than 1 minus x. So we do have two regions, above the blue line and below the blue line. So this is the region that satisfies this inequality. But now according to this graph, we consider the region that satisfies both inequalities. So this is actually x 0 to 1. Yeah, it is clear here 0 and here 1. So it is already there. So the region that satisfies both inequality is this region. Actually, this triangle plus this triangle, this big triangle. Okay, now you understand the area we should consider on this problem. So we should stay in this triangle. Uh, we don't cross these lines. How do we find the k? We know in by the definition negative infinity to positive infinity, and the same general f xy joint dx dy equal to 1. We can use this to find the k. How do we do this? So in our case, fxy is kx, so k is a constant, x dx dy. Okay, now the next thing is find the limits. So x and y. How do we find the limit? Okay, now go back to the region. This is our region. So I use x first. Yes, if I use x first, you see that here x first, then I should consider this region and this region separately. Why? And understand this way. First x change, right? So x is this change, and this one is a line, and this one this way. But after this point, after this x-axis, when you pass the x-axis, then you start from here and go to the blue line, and here you use green line, but here blue line, then it change on this x-axis. Therefore, we should consider this part plus this part. Let me write down that. So if I consider this one first, x change from 0 to what? So this line here, you see here y equal x minus 1. So x equal y plus 1. Therefore x change from 0 to y plus 1. Then y change, the minimum value of y is negative 1. The maximum is 0. Therefore negative 1 to 0. Plus, because we have two regions to consider. So this one kx dx dy. So again x and y. So when you consider this part, x change from 0 to this axis, you see that. If you don't understand this, please go back to my previous video. So then you will understand what I am talking about here. So from this you can get the x equal 1 minus y. So therefore x change from 0 to 1 minus y, and y goes from 0 to 1. You see y here change from 0 to 1. Okay, previous one we integrate with respect to x, and then we integrate with respect to y. But now I explain the other way. I first use the anyway fxy, that is kx. I use first dy and then dx. Okay, then I can change this one dy and dx. So still this equals 1. So then y limit. What is the y limit? Again go back to the region, you see this region. So y change from here to here like this. So if you consider this whole region, you start from the green and stop on the blue, and same way in the whole region. Therefore you can use this equation, y equal x minus 1 at the starting point, y equal x minus 1, and this one y equal 1 minus x. So again, see, you start from here and stop over here, and same way the same lines is from the beginning to the end. Therefore we don't have to consider two regions, and x values goes from 0 to 1. It is clear. Therefore x equals 0 to 1. Then you can integrate this. So you will get this 0 to 1 to kx 1 minus x dx. So this equal 1. Once you integrate this part 0 to 1 here, you will get k over 3 equal 1. From this k equal 3. So that is the k value. Next one, find the marginal density for y. So let me write down the definition for the marginal density for the y. This equal f xy dx. Okay, now we have to consider the regions again. Here we integrate with respect to x. So when we integrate with respect to x, x is the factor going to be changed 0 to this. Right, I start from here, then I draw lines again. So you see, when you pass x-axis, you meet the blue line instead of green line. Therefore, we should consider these two regions separately for the marginal density for y. First, I will consider this region. So, in this region, we can say y change from -1 to 0. So, first we consider this range. So, then what is the fyy? Fyy marginal equal this fxy is now we know k equal 3, say for 3x dx. So here x change what? You see again, look at here, x change from 0 to an end on this green axis. In this region from y from -1 to 0, x goes from 0 to this. Therefore, x start from 0 and end at 1 minus y. So x equals 0 start from 0 and end on the line y plus 1. Right. So then we can integrate this one. So once you integrate, you will get 3 half y plus 1 to power 2. So that is the marginal of y in this region. Now we need to find the other region too. It is y from here to here, right? It means y change from 0 to 1. How do we find for this case? Again, fy, y. So here you see x change from 0 to the blue line. So what is the blue line? X equal 1 minus y. Therefore, x equals 0 to 1 minus y 3x dx. So this is 3 half 1 minus y to power 2. Now how do we write the answer? F y marginal of y equal, we have three cases. First one I can say 3 half 1 minus y to power 2. This one, if y in between 0 and 1 here actually this one. So therefore 0 y 1, and next one 3 half y plus 1 to power 2, which is this, the region, this range -1 y 0, and otherwise it is 0. So this is the answer for the marginal density for y.